6.1 Discrete Random Variables. Okay. All right, so a random variable is a numerical measure of the outcome from a probability experiment. Its value is determined by chance. Random variables are denoted using letters such as x. Okay, and so it's all about our outcomes on those pieces. Now, discrete, just like we talked about before, means that it's countable. Whole things, people are discrete, different things like that when we're looking at those pieces. Continuous are not countable, so things that can be broken down into decimals or go forever with those. Time, lengths, those types of things are continuous. And so here are some examples as reminders. We have 15 students enrolled in this course. So this is discrete because we have the 15 different students. There's not half a person. There's not an infinite amount of people. The number of cars going through a McDonald's drive-through. Again, those are discrete because cars are whole things. We can count those pieces and we can stop during a time frame. Okay. With the speed of the car as they go past a trooper, this would be continuous because the speed could be dealt with all the way down into these decimal amounts on those, and so it's an infinite amount within those pieces. Okay. All right, so next we need to be able to identify discrete probability distributions. So a probability distribution of the discrete random variable provides the possible values of the variable and their probabilities. Okay. So for instance here, if we're shooting baskets and we have 0, 1, 2, or 3 on those, okay, and that's the shots made on those. And so next to it, it has the probabilities. So there's a probability of 0.1 or 0, 1 to make 0 shots, 0.10 to make 1 shot, 0.38 to make 2 shots, and 0.51 to make 3 shots. Okay. And so we could read those things. So for P of 3, we would say is 0.51 on those. Okay. Now, our discrete probability distribution rules follow what we talked about for our probability models in the past. And so we have those same things there. That means the sum of all the probabilities must still equal 1. So we add everything up, it has to equal 1. Also, our numbers for the probabilities have to be between 0 and 1. It can equal 0, it can equal 1. It cannot be bigger than 1, it cannot be less than 0. All right, so let's look at those. So we can see here, we have a number that's negative. That means it is less than 0, so this is not a probability distribution. Here, if we add all these together, we get 1.18, which is not 1. So again, this is not a discrete probability distribution. But our last one, if we do that, we add them all together, we get 1. We see that none of those are bigger than 1, none of those are less than 0. So that means that this is a discrete probability distribution. Now, when we're graphing these are just like graphing our relative frequency. We have our probability on the side, the number of successful free throws, or whatever we're talking about here on those, and we plot those dots with them, okay? So very straightforward, just like we've done before. All right, now let's look at the mean of these. So here's our formula for finding the mean of our probability distribution. And so it's the sum of x times the probability of x, okay? So let's look at our previous table there when we talked about our shots. And so if we wanted to do this by hand, we would go through and we would multiply our x times our p of x, and then we would add all of those results together to get 2.39 or 2.4 based on whatever we need to round to, okay? Now our calculator will actually do this. This is what we would in the past have called our weighted mean, and so that's what we'll want to look at here. So let's go into stat. We need to fill in our table. So let's go to number 1 there. We need to edit. Now again, when we're doing these, our x is going to be L1, our p of x is L2 when we're doing these, okay? And so that's what we want to look for there. So our x 0, 1, 2, and 3. And then our P of X, we said 0.01, 0.1, 0.38, and 0.51. Okay, now notice I didn't put that third column. The calculator is going to do all that math for me, so I don't have to do those. All right, so now we're going to go back over to stats. We're going to move over to calc, and we're going to do our 1 vars. Now do remember here when we did this that if you have an 83, remember to put in your parentheses. I'll write that out in just a moment so that you can see that. But if you have the 84 like mine, you want to have your L1 here in your list, and your frequency is L2. So remember there to put second 2 to put L2 in. Mine already has it, so I'm just going to go to calculate, and we can see right up there our X bar is our mean is 2.39, which is what they have. Okay. Now, again, for those that have the 83, you need to do where it says 1 dash vars on your screen, or var stat. You need to open parentheses and do L1, comma, L2, like so, before you hit enter with those. That way it recognizes your L2 column. If you just hit enter without putting that, it's going to give you the wrong answer because it's only dealing with L1. So again, make sure that you do so as that reminder, okay, for those pieces. All right. And so here, what that means for those pieces, as we look at the independent times and the value is recorded, as the number of repetitions increases, the value will approach whatever our mean is there for our population. So our sample will start getting closer and closer to our population for those. So you're going to have some questions that ask about the difference between X bar and mu sub X, which is our two means. And the bigger they get, the closer to 0 they're going to get for those. Okay, and so here, if we did our basketball shots 100 times, did this experiment, we would see that our average actually comes out to about 2.35, which is pretty close to 2.4 on those. If we were to do it 1,000 times, I bet we'd get even closer to 2.4 on those. And the more times we do an experiment, closer and closer it's going to get to our theoretical mean that comes from the table there for those. And so they show that here when we're looking at the number of repetitions in this. Notice that they get closer and closer to that bar of 2.4. Okay. All right. Now, the mean can also be called the expected value with those, okay? And so if they ask about your expected value, you are finding the mean. And we're going to do it the exact same way. So here we have a term life insurance policy. And so we have that a male buys a $250,000 policy for $350. Okay, what is the expected value to the insurance company? So to the insurance company. All right. So here we want to look at what are some pieces that they survive. So notice it does tell us the survival is 0.998937 with those. Okay, so where did they get a lot of these numbers? So for our survival there, we have that piece. Well, if they die, to get this number here, the 0.001063, this number, we just do 1 minus that number, okay, the 0.998. That'll give us what happens if they die, all right? Now, what about the cost? All right, so if the person survives the year, the insurance company gets the $350 that the person paid because they paid that amount, right, for those. But if they die, the insurance company has to pay out. Well, the person already paid $350 to them, so they're in a bonus. But when the company pays this out, there's a difference there. So the difference is a negative $249,650. Okay, and so those are the possible X values, and then these are the probabilities for that. Okay, Now, again, we would go to our table, we would do L1, we would do L2, and find our mean that way, okay? And when we do that, I'm not going to do that in a calculator because I want to use the previous information, but we would get this 8425. I did that earlier to verify it does do that. But if you put that into L1 and L2 and do your 1 vars with the L1, L2 in it, you will get the X bar up there, the mean, that does state the same thing. Okay? All right, so what that means is that the company will expect to make $84.25 for each of its client it insures. Okay, so whether they have to pay out or not on those because of the average of all those things. Because people will die during the year, so they're going to have to pay out on some people, but a lot of people they won't. Okay. All right, how about standard deviation? Now here's the formula for standard deviation. So pretty ugly and looking on those things. So again, if we go back to our shooting the ball there, for this, if we were to plug all those things in and work that out, we would come up with 0.7. Well, again, here is where the good thing is. Right over here is our standard deviation, 0.7. So by putting it into our L1 and L2 and doing our 1 vars, we have both the mean and the standard deviation right here given to us. So we don't have to work as hard to get those pieces. The calculator will do them for me. Okay? All right, and so again, here's just using the other formula for those pieces. Okay? And so finally wraps up with saying, just use the calculator because it will be easier for us. All right. So those are the things that you're going to need for 6.1.